Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle, and it's called Triptych by Oddly Even. And here are the rules. We have normal Sudoku rules apply, which means put the digits 1 through 9 once each in every row, column, and 3x3 box. We have triplers, where one cell in each row, column, and box is a tripler cell. And tripler cells have a value equal to 3 times their digit. So these are like doublers, but they're 3 times is the value instead. Each digit from 1 to 9 appears once in the set of tripler cells. So there are no repeats in the tripler cells. And then we have cages, where values in a cage sum to the total in the top left corner of the cage. So, for example, this could be specifically either a 3 or a 1 that's tripled, right? Because 1 tripled is 3 in value. So the sum of this cage would be essentially 1 tripled, which would be 3. Or if it's a 3 by itself, which is not tripled, so not tripled, this would be just the value of 3. So that's an example of how cages work. We also have region sum lines, where the sum of the values on a line within a box must be the same for each box that line passes through. So if we'll use this line as an example. The sum of these 3 digits must equal the same as the sum of these 4 digits, right? Because these are, it's basically a region sum line, right? You sum up the region, you sum up the regions on the line, and they must sum up to the same sum. That should be interesting given certain shapes in this puzzle. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so this is a 45 cage, which has only 8 digits. Therefore, the tripler must be in the cage, right? If it's not in the cage, you can never have 8 digits ever adding up to 45 from 1 through 9. It's without a tripler. So the tripler must be here, which means this cannot be the tripler. These 2 digits must sum up to the same sum. This is not the tripler. This must be a tripler then. So this must be a tripler here. And so that means the rest of this box cannot be a tripler. The rest of the row cannot be a tripler. And the rest of the column cannot be a tripler. We know this has to be so this is basically the equal to a triple of a single digit. So this must be either 6 or 9, because those are the only digits that can be sums of triple digits, and this is 2 or 3, because this is also the sum of 3 other unique digits. Okay. That means these have to be 1 through 6 at most. This is also 1 through 6 at most, to add up to this digit, right? That means the digit here if this were a 6, the other digits would add up to 39. So we would need a digit that would be tripled to add up to So the doubling of that digit is equal to 6, if that's the case. That would mean 3 would be doubled here, and this would be 2 doubled here. If this is 9, could that actually ever be the case? I think the answer to that is no, right? The tripled version here would have to add up to itself, and the plus 2 times that would be then 9. But 2 times a digit is never going to be an odd digit. So therefore, this must be 6. This has to be 2 doubled. This is specifically 1, 2, and 3. This can't be 2 because of the 2 in the column. This is also 1, 2, and 3, and none of them can be tripled. So the 3 must be tripled here, because 3 by itself is just by itself, and then the extra 2 3s, which are the tripling effect, adds up to 6, which is 45. That's interesting. The rest of this box has to be 4 through 9. So 6 obviously can't be here. This rest of this box must be 4 through 9. Okay. This is at minimum... Well, the thing is, a triplet could be there. Oh, this is a single digit here. This is a single digit. It's the sum of at least 1, 3, 4, and 5, which is 13. So this must be tripled. So this is tripled, which means this cannot be tripled, so this must be tripled too. Also, that means the rest of the box cannot be tripled. The rest of this row can't be tripled. This is at least 13, so this is 5 through 9. This is tripled, and these two must sum up to a triple valued. So this has to be something times 3. This is also something times 3. So these two digits by themselves must add up to 0 mod 3. And the reason why you know that is if you have a sum of digits and they have remainders mod 3, let's take an example. Say you had, this was 5 tripled. That's 0 mod 3, obviously. This is also 0 mod 3 because it's something else tripled. These two digits cannot add up to a remainder mod 3 because if they did, then this would be 0 mod 3, this would be 0 mod 3, and this would be a remainder mod 3. They wouldn't add up together correctly, right? So say this was 2 and 3, which is 2 mod 3. No matter what triples you have here, these can't add up if this is 2 and 3. So we know this must be a 1-2 pair here, which means this has to be 3. So 3 cannot be here. So this triplet is the digit that's tripled, it must be 1 less than this digit that's tripled, right? We add an extra 3 here. So if this is 4 tripled, that's 12, plus 3 is 15, which is 5 tripled. If this is 5 tripled, that's 15 plus 3 is 18, which is 6 tripled. So again, this digit is 1 less than this digit. So this cannot be 9. This is 5, 6, 7, 8, 9. This is 4, 5, 6, 7, 8. We know the 3 is tripled here. So and the 3 has to be in box 4, one of these two digits, because this is a 3. So because this is a 3, that cannot have a triplet here in that box, because we know specifically in box 1, the 3 is tripled here. So the triplet's one of these two. This is a triplet, so it cannot be here, cannot be here. Where is the triplet in column 2? Can't be here because the 3 is required to be tripled here. Can't be here. These can't be tripled to add up to 6, and this can't be tripled because of the triplet in the row. This can't be tripled because of the triplet in the row, so one of these two is a triplet, which means this can't be triplet, and this can't be triplet. Okay. This is 3 digits adding up to a multiple of 3. Well, you can never have 3 digits ever adding up to 27. You could have it as 24, but the problem is that this would require 7, 8, 9 to be here to be that case. And that would have a duplicate 8 here and a 7, 8, and 9 triplet. So this cannot be 8 or 9. This can't be 7 or 8 then, because again, this digit is 1 less than that digit. This is 1, 5 or 2, 4. This cannot be 1, 2 here. So this is 4, 5, which means this can't be 4, 5. If this were a 4, this would guarantee this is 5, and therefore this cage, this cell would not have a possibility. So this can't be 4, which means this can't be 5. So one of these is a 6. We're not sure which. Let's see. Okay. This adds up to at least 18. So this is at least 18 here. It could be 21. This is specifically 1 or 3, like I said, but we don't know which. Okay. This is 34. This sums up to what this digit tripled is. We know the sum of these two parts must be 45 plus whatever the triplet is doubled, right? Because we have a triplet by itself is a single digit. That would add up with the other digits in the box to add up to 45. Therefore, the extra value must be the digit that's tripled. And it has to be the double of that value because, again, we use the one singleton of that triplet to add up to 45. And the doubled version then must be the remainder from this sum here minus 45. Well, if this is 6 tripled, that means this is 18. The total of this then would be 52. 52 minus 45 is 7. So you would have to have the doubled value of the tripled digit in this box to be an odd digit, which is not allowed. So this cannot be 6. This has to be 7, which forces this to be 6. So this adds up to 21. This is 21. This is 21. This must be 21. 21 plus 34 is 55. 55 minus 45 means that the 5 is the tripled value. Because 5 doubled is 10, which is 55 minus 45. So the 5 is the tripled value here. The 3 is the tripled value here. This adds up to 21 with 3 digits, which are none of which are tripled. And it cannot have a 7. So it can't be 6, 7, 8, can't be 5, 7, 9. It must be 4, 8, 9. So this is a 4, 8, 9 triplet. That means the rest of this row has to be 1, 2, 3, 5, 6. Well, this can't be 1, 2, or 6 because of the 1, 2 pair in the column and the 6 in the column. This can't be 2 or 3. So we know there's a 2 in one of these cells here. We don't know which. This can't be 6 because of the 6 in the column. We know this adds up to 21. So that's 38 for these digits. Huh. Interesting. Does that tell us anything? I'm not really sure. Um, hmm. This can't be 3 because one of these is a 3 there. This adds up to 17 without any tripling. But that's still pretty wide variety of possibilities. Um, 6 and 7 cannot be here. 6 cannot be there. So where is the 7 in column 5? It must be here. Okay. We are guaranteed a triplet here. We don't know what the value is, though. We know this adds up to 21. Hmm. Seven has to be one of these two. This adds up to 21 also. So does this. Only one of these digits could be tripled, or tripled, though. Hmm. But the tripling could actually... Oh, interesting. Huh. So these add up to 21. But what triple values are there? 5 could be here. This could only be 1 or 4, possibly. Because we already have 2, 6, 7, 3 in triplets. In tripler cells. Let's say none of them were tripled. So all of these were basically non-tripled. Obviously, none of these could be 4, 8, 9. So that would force this to be 4, because if this is 4, 8, 9, that would eliminate... Well, this could technically be 4, 8, 9 there. So if all of... This would then be 1, 2, 3, 1, 2, 3, and 1, 2, 3. This is 1 or 3 here. So 2 would have to be one of these, which means this couldn't be 2. So this would... 1, 3 would match this 1, 3. That's assuming none of these are tripled. Which is fine. We would need a 5, and we would need a 6 in column 9. So one of these would be 5, so it'd be 5, 7, 9. The other one would have to be 6, 7, 8. So this would have to be a 4. You'd have either 5, 7, 9 or 6, 7, 8 here. Obviously, this couldn't be 6. This would be 5, 7, 9 or 6, 7, 8. So 5 or 6 could not be here. So if this were 5, this would be 5, 7, 9. This would then have to be 6, 8. And I guess this would be... Well, you couldn't have 5 be here, if that's the case. So this could never be 6, 7, 8. Because the 5 has to be the tripled part here. So this would then have to be 6, 7, 8. Which would force... sorry, this would have to be 5, 7, 9. Which would mean this is 6, 8. And this would be 7. And the 5 would be tripled here. But then the problem with that is, since none of these are tripled here, where's the triple in column 9? Can't be the 2, can't be the 3, it has to be the 1 tripled. Which would be here. So the 1 tripled would have to be here, because the 3's already tripled here. And the 2's tripled here. And this can't be... I guess that could work. This could be 1 tripled here, which would force this to be 3. That would be 3 here, then. So this would be... One of these would be 1, 2 tripled. So none of these are tripled. This is 5 tripled. We have 3. 1, 2, 3, 4, and 9. That's 19. 5 tripled is 15. So that does work. Three would have to be here. This is 5, 7, 9. So this would not be tripled. Tripled would be one of those two. This would have to be what? 5, 6, and 7? Okay. So far this is looking okay. So this is 1, 2, 3, 4, 9. No, 3. 1, 2, 3, 4. 1, 2, 4, 5, 9. And 2 cannot be either of these. We have the 1 tripled here, the 3 tripled here, the 5 tripled here. 4 cannot be tripled here. Right? Because if 4 is tripled here, that would add up to 12, and 3 other digits can never add up to less than 6. So this would have to be whatever's tripled here, which means obviously none of these would be tripled, none of these would be tripled. This wouldn't be tripled, so this would have to be the tripler here, which would force this to be 5. This couldn't be 6 tripled. Can't be 1 tripled, or 2 tripled, or 3 tripled. It's either 4, 8. It cannot be 5, 7, or 9. So this is 4 or 8 tripled here, if that's the case. To add up to 17 for 4 digits without 5, 7, and 9. 17, it could be 1, 2, 6, 8, but we are guaranteed 3 is in that box, so that doesn't work. So 3, 17 minus 3 is what, 14? Yeah, 14. So 3 digits adding up to 14. So 1 can never be here. We have 3 here. We don't have 5, 7, 9 available. That means 1 can never be here. So this would have to be 1. Make that 2. This would have to be 2, 4, and 8 to add up to 14, which is a contradiction. Right? Because this triples, the digit in the triple cell can't be 1, 2, or 3. We tried 4 tripled in the cage, that doesn't work. 5, 7, and 9 are eliminated. 6 can't be in the triple cage, so this would have to be 4 or 8. But 2, 4, or 8 would have to be with a 3 here to guarantee that that's the case. So, we've just shown that the tripler has to be somewhere along the line. I guess it could have been here. But if that... Well, What are the rest of the digits in box 9? We have 1, 2, 3, 5, 6, and 7. Okay. Yeah, that's fine. So we showed that doesn't work if these are all just non-tripled in the rest of this equals this region sum line. So somewhere along these 4 cells, there has to be a tripler. Okay. It could be 5. So 5 tripled. That does work. You can't have, obviously, 8 tripled, because that already adds up to 24, and you can't have 9 tripled. But you could have potentially 1 or 4 tripled, too. So the possibilities are 1, 4, 5 tripled. And we guarantee you have to have one of those. I think it might be 5 tripled here, but I'm not certain of that. Cannot be 1 tripled. If it's 1 tripled, that's only 3 in value, and the 2 other digits would have to add up to 21 minus 3. which is just 18. So 2 digits adding up to 18 is not possible without a tripler. And we already have the 1 tripled. So it has to be the 4 or the 5 that's tripled. Interesting. If it's 5 tripled, the other 2 digits add up to 6. Because 21 minus 15 is 6. If it's the 4 tripled, the other 2 digits add up to 9. Okay. That seems reasonable. So, if it's the 5 that's tripled, to add up to 21, you need 2 and 4, necessarily. Okay, so then this would be a 5-2 pair here, if that's the case. And this would be 4. Then these 3, we know if the 5 is tripled, it has to be here. If the 4 is tripled, it has to be here. The rest of these digits can they add up to 34? They would, because 2, 4, and 5 add up to 11 without tripling. And 45 minus 11 is 34. So if this is 5 tripled, it has to be 2, 5 here, and then this is 4. That means these 3 digits would have to be tripled, or not tripled. Because, well, they would have to be. Because again, you can't have a 4 here. So assuming 5 is tripled here, that would guarantee this is 4, and these cannot be 4 tripled. They can't be 5, 6, 7 tripled, because 6 and 7 are already taken in the triplers. 8 and 9 are too big, 1 is too small, and 2 or 3 are already taken in triplers. So, if this is 2, 5, and this is 4, obviously 4 can't be tripled here. So this is either 5, 7, 9, or 6, 7, 8. Either way, 7 has to be one of these 3. We'd have an 8, 9 triplet in... So one of these would be 8 or 9. This would be 8 or 9. That would eliminate 8 and 9 in the rest of the column. So 7 also couldn't be there either. So that still kind of works. Okay, that's fine. If this is not the triplet and 4 is a triplet here, the other 2 digits must add up to 9. Could you still have the triplet here? No, because it'd have to be 5 tripled with 2 and 4 guaranteed. So the 5 tripled would have to be here. This would be 4 tripled. So either way, this can never be 4, essentially, is the point. Because if this is we've tried it without tripling anything on the line, and that doesn't work. Just the way that these boxes work. It would guarantee that we'd have to have here, this would be 3, it's really complex. So, either this is tripled here and it's a 5, or this is tripled here and it's a 4. If it's 5 tripled here, that makes this 4 and 2. And this, because this can't be 2, this can't be the 5 tripled, because the tripled 2 is here. And that eliminates the tripler and the 5 and the 2 from that row, or this box, or this cell specifically. So that would force this to be 4. Since this is 4, this could not be tripled. So this would have to be 5, 7, or 9, adding up to... This would be 4, and therefore this couldn't be 4 here. And it couldn't have 4 rest of 4 in the rest of the column. If this is the tripler, it has to be a 4. Because it can't be 1. 6 and 7 are already taken. Can't be 8 or 9. 2 or 3 are also taken. And 5 is taken by the cell here. So 4 would have to be. So 4 is guaranteed to be one of these 3 digits. We just don't know which. 4 tripled would mean it adds up to 12 after the tripler. That means the other 2 digits must add up to 9. So it could be 1827 or 36. It cannot be 36 because the 3 and the 6 are both in row 6, and that would force this not to be 3 or 6. So before, it could be 18 or 27. It could not be 45 because we already have a 4 in that column. So there is no 3 here. This cannot be 4, 8, 9 because if this is 4, obviously these can't be 4, so this would be 4. This would be an 8, 9 pair, which would eliminate all possibilities for this cell. It cannot be 5, 7, 9. It would have to be 6, 7, 8 in this case then. Interesting. Because the triplet could not be here. If it's 5, 7, 9, the 5 is tripled, guaranteed. So it would have to be 6, 7, 8, and this would be 7 or 8 here. So if that's the case, this is 4. Again, it's with 1, 8 or 2, 7. So this is 7 or 8 guaranteed here. This is 7 or 8 guaranteed here, which means this could not be 7 or 8. Because this is 7 or 8. One of these is 7 or 8. So this would have to be a 6, which would force this to be 7 or 8. So we are guaranteed, if this is the tripler, 2, 5, and 4, this has to be 5, 7, 9 or 6, 7, 8. Which means there's a guaranteed 7 here. If this is 4 tripled, it's either with 1, 8 or 2, 7, and this is 7 or 8. Therefore, this could also not be... one of these is basically guaranteed to be 7, which means this cannot be 7 here. Okay. If this is 6, 7, 8, this could not be 4, but it could be 5. So this 7, 8 would force this to be a 9. So one of these are a 9 too. Guaranteed. One of these 5 is a guaranteed 8. I guess this could be a 6 then. It could be 5 tripled or a 6. Hmm. Can the tripler be in the cage? It can if it's 1, but only if it's 1. What would that mean, though? The tripler being in the cage, which means that's 1, which would mean this is not tripled, which would mean this is 2, 5, and 4. That would mean this is 3. If this is 1 and it's tripled, let's try that. So this is 1 tripled. That would mean the tripler would have to be either in the cage, which it can't be because 1 and anything 4 or above tripled never adds up with 3 other digits to add up to 17. It's because 4 tripled is 12, the other 3 digits would have to add up to 5, which is not possible. So therefore, this would have to be tripled, which would be the 4. So this would not be tripled here. And so neither of these would be tripled. So none of these would be tripled. This would be the 5 that's tripled. So this would be 4 tripled with 1 8 or 2 7. Because it cannot be 4 5 because we already have a 4 in that set. It can't be 3 6 because this can't be 3 or 6. That means this could not be 4. This has to be 6. So this can't be 5 or 6 here. This can't be 2 or 5. This becomes 7 or 8. That would mean this is 9. This could not be 6. The 5, the 1 cannot be any of these. So this is 2, 3, or 5 here. This is 1 or 2. And this is 1, 2, or 3. Okay. 4 digits adding up to 17 without a tripler. And without a 4. You can only be missing 1 out of 3 or 6. 5 could not be here. 5 has to be one of these, so this can't be 5. Right? 3 and 6 cannot be either of these, cannot be here. So 1 out of 3 or 6 at least is here. It could be both. So 4 is guaranteed here. The rest of this is 1, 2, 3, 4, and 9. 1 obviously can't be any of these. This can't be 2. 9 cannot be here. Okay. No 4. You can't have 1 and 2. So I think it means you have to guarantee a 3, right? So you don't have 4. If you don't have 3, you could only have 1 out of 1 or 2. So the minimum then would be 1, 5, 6, 7, which is 19. So you would have to have 3 here. So 3 here. Do you have to have 6? Possibly, possibly not. Say you didn't have the other 1 or 2 here. I think you have to, right? We know total-wise, this adds up to what? As digits, not with a tripler. It would be 4 and 9. That's 13. So these two digits must add up to 15. 17 plus 13 is 30. 45 minus 30 is 15. So this would be 6, 7, 8, 9. Obviously, this couldn't be 6. This couldn't be 9. This cannot be 7 and 8 because that would eliminate all possibilities for this region sum. So this would have to be 6 and 9. Okay. So that's guaranteed to be 6 and 9, which means 9 cannot be here. Therefore, this must be 9 here. This is a 2, 3, 4 triplet, which eliminates 2, 3, and 4 in the rest of the column. So this can't be 2, 3. This must be a... This can't be 6. It's 7. Which means this can't be 7. So one of these is 6. This can't be 4, so this is 8. Which makes this 4, which makes this 5. So then this would have to be 3, 1, 8, or this is guaranteed to be 3, so this can't be 3 here. Therefore, this is a 2, 6 pair here, which means this can't be 2. This is a 3, 5 pair, which means this can't be 3. This has to be 1. That means this cannot be 1 and 8 here. This is 2, 4, 7. That forces this to be 8, which makes this 7. This has to be 1, 3, and 8 left. And that does add up to 17. So far, that's all okay. One of these has to be the tripler, because these can't be, so this can't be 3 here. So this is all looking fine-ish. Okay. So that's not helpful, unfortunately. Because that does actually work. I was hoping that we'd run into a contradiction there, but we didn't. Maybe we have to use this? I don't know. This is obviously at least 15. This does have a tripler guaranteed here. Can it? Well, You could have a tripler here, though, also. That's the thing. This also is 17 without any triplers. Oh, interesting. Okay. We know 8 and 9 cannot be the tripler here. Because this is a 4, 8, 9 set. We know 8 and 9 cannot be the tripler inside these cages. It could be the one here, though. We know the 5 is a tripler here. The 3 is a tripler here. So if this is 8 or 9 as the tripler in either of these cases, I guess with this one's less restrictive, but if this were 8 or 9, you would have to have a tripler here, right? 3 digits by themselves can never add up to 24 minimum, plus 3 other digits. That would be 30 at least. Without a tripler. So this could be a tripler here. Um. Huh. Hmm. Obviously, you still could have 1 as a tripler here. So that's not the... Well, can you? That would be interesting. We know there's a guaranteed 1 or 2 in the rest of row 6. One of these has to be 1 or 2. We just don't know where it is, though. Let's go rest of column 5. It has to be 3, 4, 5, 7, 8, and 9. And this is 3, 4, 5, 7, no 7 with 8 or 9 there. Okay. What else do we have then? So the possibilities left in the tripling spots are one of these is guaranteed to be okay. 4, 8, and 9 cannot be here. Oh, what does that mean? We know 5 is guaranteed triplet here. 3 is guaranteed tripled here. That means 1 must be tripled here. Because 4, 8, and 9 cannot be tripled here. Where are they going to be? They can't be here. This is 3, this is 2, this is 6, this is 7, that's 5. So the 4, 8, and 9 must be tripled here, here, and in box 6. So box 4, box 6, box 7 requires the 4, 8, and 9 tripled. So this must be the 1 tripled here. Because it cannot be 4, 8, or 9. So this is guaranteed to be 4, 8, or 9 tripled. Huh. That doesn't necessarily tell us much. Okay. So we know the 1's tripled here. 4 can never be tripled in the cage. So this can't be tripled here. This is then singleton triples here. Sorry, none of these are tripled, essentially, in this cage. We went through the scenario when this 1 was tripled here. We don't necessarily have that given. It could be 3 here, and then the 1 tripled is tripled somewhere else. Uh, hmm. Right. This gets to my weakness. I'm not good with region sublines. I don't particularly enjoy them. I don't really understand them too well, but I've done a decent amount of them. I'm just not very good with them. We know this is 6. I'm pretty sure this can't be 9 tripled. That's 27. Well, I guess you could have 8 tripled here. Can you ever have 4 and 8 tripled here? Or 4 and 9 obviously would be the most restrictive. But 4 and 8 would be interesting also. That would mean you would have a difference of 12. So say this was 4 tripled, and this was 8 or 9 tripled here. Would that work? But let's work through 9 tripled. Actually, sorry, 4 tripled here, and then 8 or 9 tripled here. Yeah, that would be better. So 4 tripled here. That would be 12 plus 8 and 9 maximum, which would be 17. So that's 29. And I think the answer to that is no, right? So 4 tripled is 12, plus 8 and 9 is 17. 12 plus 17 is 29. If you had 8 tripled here, that's 24. 24 plus 1, 2, and 3 is 6. And that's 30. So this can never be the 4 tripled here. That means whatever's tripled here but you could have this be the 4 tripled? Maybe. No. 8 tripled by itself doesn't work. So if this is 8 or 9 tripled, and this is not tripled, right. So we were assuming this is 4 tripled, and this is 8 or 9. It just doesn't work, because this adds up to 29 at most. This adds up to 30 at least. So this cannot be 4 tripled. What happens if we don't have this tripled, and this is the 4 that's tripled? Can this ever be 4 tripled here, actually, is the question. If this is 4 tripled, so obviously 4 tripled doesn't work. No, and the answer is no. So this can never have 4 tripled here. It has to be 8 or 9 tripled in this box. Because, again, if 4 is tripled here, either way, on the line or without the line, the maximum of these would be, if it's 4 is tripled here, with 8 and 9 would be 29. If this is not 4 tripled, that would be 7, 8, 9, which is 24, and this would guarantee have to be 8 tripled plus 1, 2, and 3, which is at least 30. So this must have an 8 or 9 tripled here. I guess you could have 8 and 9 tripled here and then the 4 tripled here. So if the 4 is not tripled here, that would mean that the 8 or 9 has to be tripled here. Sorry, this would be 4 tripled here. This would be 8 and 9, and that could work, right? Because this would be at least 12, and then you have 7, 8, and 9 possible. You could not have 7, 8, 9. Because then the minimum for this 4-cell cage would be 2, 3, 5, 6. And that adds up to 16. So it would be at minimum 6, 8. Well, you can't because this is 1, 2, 3, or 5. Huh. So it'd be 5, 8, and 9. So if you have 4 tripled, the maximum of that is 5, 8, and 9. So 4 tripled is 12, plus 5, 8, and 9. That's 22. So that's 12 plus 22 is 34. And 8 tripled plus... Ah! That doesn't work. So again, this has to be 5, 8, and 9 at maximum with the 4 tripled, if this were 4 tripled. So, if this is 4 tripled, the problem is that this at minimum would have to have 8 tripled plus a minimum of 4 and 5 here, because you can't have 1, 2, and 3 because of the 1, 2, 3 triplet in that box. So 8 tripled is 24. Oh no, that works. Dang it. Ugh. 4 and 6. Never mind. That does work. I thought I was reaching. I thought I got to a contradiction there. That's not. So this could be 4 tripled here, with 5, 8, and 9. Ugh. Dang it. Okay, no good. Right, 4 tripled, 12, that's 34. Then this could be 8 tripled with 4 and 6. 8 triples 24, plus 4 and 6 is 10. That's 34. So it does actually satisfy that. So this could actually be 4 tripled here. Dang it. I thought I had found out this could not be 4 tripled. If this is the triplet, it can't be 4. Because if this is a triplet, that means this adds up to 17. This adds up to 21 without the triplet. Actually, yes. Therefore... Huh, that's interesting. If this is not the triplet, Sorry, if this is the tripler, these add up to 17, and this adds up to 21. That's 38. So this must add up to, for the other digits, 45 minus 38, which is 7. Well, 4 here would mean 3 is here, which is not possible. And 8 here would be negative 1 here. 9 would be negative 2 here. So that's not possible. So this can never be the tripler. That's fascinating that we get to that statement there. So again, if this is the tripler, say this is the tripler, that means this can't be the tripler. This adds up to 21 by itself. This adds up to 17 without a tripler. So that means this total adds up to 38. These two digits left must add up to 45 minus 38, which is 7. But we know this is a 4, 8, or 9 here. If this is 4, this would have to be 3, and we'd have a duplicate there. If this is 8, this is negative 1. And if this is 9, this is negative 2. So this can never be the tripler, which means the tripler is here. And it has to be 4. So we know this is the tripler, which eliminates the tripler in the rest of the column. This has to be the tripler. It's a 4. Because it cannot be 8 or 9 or 1. And the 3 and the 5 here can't work because we already have a 3 tripler here and a 5 tripler here. And we have 6, 7, 2 accounted for in the triplers. So this is 4 with 1, 8 or 2, 7. We cannot have a 5 tripler here because that forces this to be 4. And then that would have a contradiction. We'd have 2 4s in the same column. So this must be non-triplet 5. This is 6, 7, or 8 because it can't be 4, 8, 9. If this is 4, this would be 8, 9 pair, which eliminates all possibilities here. It can't be 5 because the 5 is in the tripler. So it has to be 6, 7, and 9. Oh, sorry, 6, 7, and 8. Which means, and this is 7 or 8. One of these 3 is 7 or 8. That eliminates 7 or 8 in the rest of the column. So this can't be 8. This is 9. This can't be 7 or 8. So this is 6, which forces this to be 7 or 8. So this is 7 or 8. This is 7 or 8. This can't be 9. This is a 4, 8 pair. This 6 eliminates 6 in the rest of the column. We need a 5 in column 9. Can't be here because of the tripler. That means it must be one of these two cells. So this cannot be 5 here. And this is 1, 2, or 3, and this is 1, 2, or 3. The rest of the column have to be 1, 2, 3. Sorry, the rest of the box has to be 1, 2, 3, 4, and 9. But 2 cannot be here. We have a 5 guaranteed in one of those 3. We're not sure which. This 6 means this can't be 6 here. So 6 has to be in box 2 in row 1 somewhere. Okay. That means this is 4 with 1. Okay, so this adds up to 13 as digits, right? Because the 4 is tripled. This adds up to 17, so these two add up to 15. And it cannot be 7, 8 because that would eliminate all possibilities for this cell here. So this then must be 6 and 9, which eliminates 9 here. So 9 has to be one of these two. 6 is here, so this can't be 6 here. This must be... we have to have 3 and 5 guaranteed here, and 3 cannot be here. And this is 1, 2, 7, or 8 here. Right? It's either 1, 8 with 3, 5. 3, 5 add up to 8, and 1, 8 adds up to 7. 2, 7 adds up to 7. And those are the possibilities. This 9 eliminates 9 here, and then here. So this is 8 and 9 as a tripler. This must be 8 or 9 as a tripler. And because of that, since 8 or 9 is guaranteed to be the tripler here, that means this is at minimum 30. So this has to have a guaranteed 8 or 9 tripler here. So this cannot be tripler here. It must be one of these two, which means this can't be the tripler here. So this can't be 3. So we know 3 is here, which means this cannot be 3 here. That means 3 is here, 3 is here, and then 3 must be here in this guaranteed 17. Interesting. This can't be 6 because of the 6 in the row. This can't be 6 because of 6 in the row. Where is the 6? In row 4. Has to be here. So this is 6. It cannot be the tripler. So this must be the tripler here, and it must be 8 or 9. We don't know which. Okay. That means this can't be 6 here. So 6 has to be one of these 3. Okay. If this is a 6, this has to be then 3 here. That adds up to 9, so the remaining 2 digits must add up to 17 minus 9, which is 8. Well, we've eliminated 2, 6, and 3, 5, so it would have to be 1 and 7. So if this is 6, this would have to be 1, 3, and 7 here. That would force this to be a 2. This can never contain 8 and 9. And the reason why we know that is this is 8 or 9, and this must be 8 or 9 here as a tripler, and they both see these cells. So none of these can be 8 or 9. To add up to 17 without an 8 or 9... Seven, 6, that's 13, so 1, 3 with that. 7, 6, 1, 3. 5, 7, 1, 2. So 6, 7, 5, 7. No. 6, 7, 1, 3. 5, 7. That's 12. 1, 4. Or 2, 3. 4, 7. That would have to be 1, 5 with it. So there were the possibilities. Okay, 1, 7, 6, 5, 1. No, 7, 6, 3, 1. 7, 5, 1, 4. 7, 5, 2, 3. 4, 7 would have to guarantee with 1, 5. 3, 7 would be 1, 6, and 2, 5, so that's fine. So 5, 6. I think that has to be 1, 4. No, it's 1... It would be 2, 4, 5, 6. 4, 7 doesn't work because you have to have a 5 or 6 with it. Right? 4, 6, 4, 7 adds up to 11. 17 minus 11 is 5. Or sorry, 6. 2 digits adding up to 6 has to be 1, 5 without a 4. 5 and 6 works with 2 and 4. That leaves you a 6. 4 and 6, that's 10. 17 minus 10 would be 6. But you don't have 1, 6, you would have to have 2, 5 in between, so it's the same as that. And then 4, 5 does not work. 2, 3, 4, 5 adds up to 14 as the highest digits. So those are the possible combinations. That's interesting. But we know there's a 3, right? Yes, we are guaranteed a 3 here. So since this is 3, it cannot be 1, 4, 5, 7 or 2, 4, 5, 6. It's only 1, 3, 6, 7 or 2, 3, 5, 7. So 7 has to be one of these digits also, because it cannot be here. Therefore, this can't be 7 here. So we have... So either this is 1, 3, 6, 7, with this being 6, and this is 1, 3, 7. Or these are both 2 and 5, with 2, 3, 5, 7 here, and this has to be 1. Possible. Um, so there's no 1 in anywhere else in box 7, but that's not helpful. Okay. This is the tripler, which means this cannot be a tripler here. So this is tripler here, which forces this to be 4. So this can't be 4. This can't be 4 here. That doesn't tell us much. This can't be 8 or 9 because it sees both the tripler cells, and these are an 8 and 9 pair. This is guaranteed to be 7 here. Again, 1, 3, 6, 7, and 2, 3, 5, 7. So this can never be 1. If this were 1, the 6 is only here, right? So it's 6, 1, 3, 7. Or this could be 2, 5, 2, 3, 5. So this is 1, 3, 7, or it's 2, 3, 5, 7. We don't know which. And 1 has to be here or here. If this is 6, so if this is 1, 3, 5, 6, so obviously if this is 2, 3, 5, 7, then this is 1. If this is 1, 3, 6, 7, where is the 2 in row 7? It has to be here, so this cannot be 5. Therefore, we have a 1, 2, 1, 2 pair in column 3, which eliminates 1 and 2 in the rest of the column. This can't be 3. It's 4, 5, 7, 8, 9. Can't be 6, can't be 1, 2 pair. 7, 8, 9. So this is guaranteed to have a 1 or 2 with it. Okay. Huh. This adds up to 21, but we don't know what that means. Rest of the box, it doesn't have a 6. Still pretty, doesn't have 2, doesn't have a 6. Yeah, it adds up to 21. That means the other 4 must add up to 21. No, 20. Sorry, 45 minus 21, which is 24, minus 2, which is 22. And we know there's a 6 there. This is kind of convoluted. We know the 1 is tripled here. So this can't be 1. Okay, this is 2, 3, or 5. Um, hmm. Okay. 20. Do we want 4 digits adding up to 21 without 2 or 6? Or do we want 4 digits adding up to 22 with a 6? I think we want that one, right? 4 digits adding up to 22 with a 6. That means it's 22 minus 6, 16 for the other digits. So it could be 178. One, 6, 7, 8 adds up to 22. Without 1, what? You have 2. You can't have 2. 3. 3 and 6 is 9. Huh. But the problem is we don't have any guarantee of what those are, right? Anyways, so this is 3, 4, 5, 7, 8, 9. No 6. This cannot be 2 or 6, so we have 1, 3, 4, 5, 7, 8, 9. This obviously can't be 3. This can't be 3. This is just a lot of math. That's the only really hard part of this, is trying to figure out this math here. The logic was fairly solid, but yeah. One out of 1, 2, or 3 is here. That means 1 has to be here. But that doesn't really tell us too much. 1 of 5, 7, or 8 is here. That also doesn't really tell us too much. Okay. If this is 8 tripled, that's 24, right? This 7 means this can't be 7 here. If this is 8 tripled, that means this is 9 tripled here. So that would mean this is at least 13. Sorry, at most 13. So 8 tripled. Oh, that's interesting. So say this is 8 tripled. This is at most 6 and 7. That means this is 9 tripled here. So you have a net negative of -3 from this set. That means this must add 3 unique digits here, must add up to 13 at most -3, which is 10. Well, 3 is here. Only 1 out of 1 or 2 is here and here. So you can't have both 1 and 2 here. So wouldn't that necessarily force this to be 1, 4, and 5? But the only ways you can add up to 17 are 1, 3, 6, 7, or 2, 3, 5, 7. Without 8 or 9, right? Because it can't have 8 or 9 here because these are an 8, 9 pair. And they all see these cells. This says 4, 7, 8, 9 here in the row. So if this were 8 as a triplet, this would have to be at most 10, 13 minus 3 difference. Sorry, this would be at most 13, which means this would have to be 10 at most. Again, 1, 2, 7 is ruled out because we can't have 1 and 2 here and here. We can't have 1, 3 or 2, 3 because of the 3 here. So it can't be 1, 3, 6 or 2, 3, 5, and therefore the only remaining set is 1, 4, 5, but then that eliminates all possibilities for this 17 cage. So this can never be 8, right? If we tried this with a smaller digit, it's even worse, right? 6 and 5 is 11, minus 3 is 8. So you're guaranteed a 1 here, which forces this to be 2, 3, 5, 7, but then that eliminates 2, 3, and 5, so you can't have 1, 2, 5 or 1, 3, 4 adding up to 8. And if you have 6 and 4 here, that's 10, which forces this to be 1, 2, 4, and again, you can't have 1 and 2 in the cage and on this line both. So this has to be a 9 here, which means this cannot be 9 any of these spots. That means 8 has to be here in the triplet. So this cannot be 8 here. So 8's here, which means this can't be 8. This can't be 9 anymore. This 9 eliminates 9 here and here. That means one of these is a 9. This is 8. So these two add up to these 3 digits plus... So these 2 plus 3 adds up to these 3 digits here. Okay. What does that mean? That means this... What is this digit? Well... This is at least 9 tripled. So again, the rest of these with the 8 tripled is equal to 9 tripled plus these 2 digits. So since 9 tripled is 3 greater than 8 tripled, that means if it's 6 and 4 here, that's 10. So these must add up to 13 without the 8. Okay, what does that leave 4 here? So 6 and 4 means this is 13. 6, 4 is 10. That means this is 13. 13 plus 8 is 21. 21 plus 17 is 38. 45 minus 38 is 7. So that does work if 4 is here and 7's here. If this is 5, that means these 3 digits without the 8 must add up to 11 plus 3, which is 14. 14 plus 17. This can't be 9 here. 14 plus 17 is 31, plus 8 is 39. So that would force this to be 6, which is not possible. So this can't be 5. And if we try 7, that's 13 here. That's 16 here. 16 plus 8 is 24. Sixteen plus 8 is 24. Plus 17 is 41. 45 minus 41 is 4. So this is guaranteed. That's interesting. This is guaranteed to be 4 or 7. This is guaranteed to be 4 or 7. And these are different ones. Right? So if this is 4, that means total this adds up to 6 plus 4, 10, plus 9 tripled, which is 27, 37. 8 tripled here. So if this is 4, this is guaranteed to be 7. This is 17. 24. So 45 minus 24 is 21. 21 minus 8 is 13. 13 plus 8 tripled, which would be 24, is 37. So that adds up. Or if this is 7, that means this is 6 plus 7, which is 13, plus 9 tripled, which is 27. That's 40. This is 4. So these are opposites no matter what. Interesting. Which means 4 and 7 can never be here. Interesting. That means 4 and 7 can never be here either. Because these both see this cells. So A has to be one of these two or this one. So again, if this is 40, that would make this 4. So 45 minus 21 is 24. 24 minus 8 is 16. 16 plus 8 tripled, which is 24, is 40. So that works either way. So this cannot be a 4-7 pair because both of these 4 and 7s have to be different ones. And one affects the other. So if this is 4, that's 7. If this is 7, that's 4. That means this can't be 4 or 7. It has to be a 5-8 pair here, which eliminates 5 and 8 in the rest of the column or box. This can't be 5 or 8. It has to be a 4. Actually, we know the 7's here. So since the 7's here, this can't be 7. This is 4, which makes this a 7. That makes this a 4. So this must add, this 4 eliminates 4 here, so this becomes a 5-1 pair. This 5 eliminates 5 here, so that's 3. This can't be 1 or 5, so that's 6, so this cannot have a 6 here. Therefore, this must be 2, 3, 5, and 7, adding up to 17. And 3 cannot be here. This is a 2, 5, 2, 5 pair, which eliminates 2 and 5 in the rest of the row. So this can't be 2. This is 1, which makes this 2. So none of these can be 2. This has to be this 4 and 5. This can't be 1 here. So one of the is one of these two, which means one of these two is a triplet. So this cannot be the triplet here. That means this can't be the triplet here. So this is the triplet here and is an 8. This 5 eliminates 5 here. This can't be 2 or 5. This can't be 2 or 5 because of the 2 or 5 pair in the box. This is 4. This has to be 6. And this cannot be 4, 5, or 7. So this is 9. That means this can't be 5, 8, or 9, or 4. This is a 3, 7 pair, which eliminates 3 and 7 in the rest of the box. This can't be 7. This can't be 4. This can't be 1 because of the 1, 3 pair in the column. Okay, this can't be 4 because of the 4 in the row. This can't be 2, and we can't have a 7. Therefore, this is 1 or 8 here. And therefore, this 1 or 8 must add up with 1 or 8 to add up to 9, to add up with the 12, to add up to 21. So this must be 1 or 8, which means this can't be 1 or 8. This has to be a 5. That makes this 8, which makes this 1, which makes that 8, which means this can't be 1. These can't be 8. This 8 eliminates 8 here, so this is 5, which makes that 8. This 5 eliminates 5 here, so it's 4, which makes this not 4 or 5, that's 7. This has to be a 5, 9 pair here, which eliminates 5 and 9 in the rest of the row. This has to be, what, 2, 2, 3, and 7. So 7's one of these two, which means 7 can't be here. Okay, 3 and 5 cannot be here. This is a 4, 7, 8 trip. 4, 7, 8, 9. This can't be 3 or 5. It's 4, 8, or 9. Cannot be 9 here. Where's the 9 in box 8? Can't be here, so it must be here. This 9 eliminates 9 here, so it's 5 and 9. We have 2, 4, 8 remaining in row, or box 8. That eliminates 2, 4, 8 in the rest of the row, so this can't be 2. This can't be 2. It can't be 6. We have a 1, 3, 7 triplet. Actually, the 1, 5 eliminates 5 here. Where's the 5 in column 9, then? It has to be here. This 8 eliminates 8 here, so it's 7, which means this can't be 7, so that's 8. So this can no longer be 7. This can't be 8. This 5 eliminates 5 here. So 5 has to be one of these two, which means that's the triplet. So this cannot be the triplet here. So this must be the triplet here. So this is 1. That forces this to be 3, which forces this to be 7, which makes that 3. That 3 eliminates 3 here, so this is 2, which makes this 3. That's 3 in the corner. We celebrate because we're getting close to solving it. This 3 eliminates 3 in the rest of the box. This can't be 2 or 3, so this is 7. This can't be 2, 3, or 7, so it's 6. 7 eliminates 7 here. This 8 eliminates 8 here, so this is 4. This is 8. We have a 2, 3 pair here in box 6, so that forces this to be 7. This 1 and 4 eliminates 1 and 4 here, so that's 9. This can't be 1, 4, or 9, so this is 2. 2 eliminates 2 here, so this is 3, which makes that 2, which makes this 1, which makes that 2. This 1 eliminates 1 here, so it's 3 and 1. This can't be 4 because of this can't be 4, 8 because of the 4 in the column, so this is 2, which means this can't be 2 here. None of these can be 2. This 9 eliminates 9 here and 9 here. Remaining digits in, well, this 6 eliminates, this 6 here eliminates 6 here, so this must be 6 here. Remaining digits in column 6 are what? 3 and 5. Okay. 3 eliminates 3 here, so this is 7, which makes this 3. The 3 is a triplet here. So this is a tripler, which means this can't be tripler, which means this can't be tripler. So this is tripler here, and is the 5. So this cannot be 5 here. This 3 eliminates 3 here, so this is 5, which makes that 3. This adds up to 8. So the remaining 2 digits add up to 21 minus 8, which is 13. So 1 cannot be here, 1 has to be here. Cannot be 5, 8, or 6, 7, so it must be 4 and 9. So this becomes a 4, 9 pair, which eliminates 4 and 9 in the rest of the box. This must be 7, this must be 8. This 8 eliminates 8 here, so this is 4, that's 8. 4 eliminates 4 here, so it's 9 and 4. 4 eliminates 4 here, so it's 1 and 4. 4 eliminates 4 here, so it's 5. This can't be 5 or 8, so that's 1. This 5 eliminates 5 here, so it's 2 and 5. Remaining digits in column 1 are 2 and 8. This can't be 2 because of the 2 in the row, so this is 8, that's 2. This is not the doubler. That leaves this as 4. And this as 9. Whew, that was pretty hairy. Yeah. The only hard part was just calculating all the different possible sums. It was just, yeah, it sort of got bogged down there. I love the logic in the early part. That was a lot of very cool logic. And even this logic here in box 6 was very interesting. But then the rest of it just sort of bogged down into, okay, what are the possibilities? And then we had to bifurcate, quote unquote. That's just the only way you can really solve it, right? You have to go through and say, what happens if this is a 4? If this is a 4, then this becomes 7, blah, blah, blah. What happens if this is a 5? If this is a 5, that doesn't work. If this is 7, what happens if that's the case? That's a bifurcation. It's just going to happen. You know, that's just sometimes what you have to do. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.